Thank you for having us here. I'm really honored to be here and to talk about microservices architecture. Um, this talk is actually an evolution or the second version of the presentation I had last month at the AWS reInvent conference. If you guys are familiar with Amazon and AWS, they organize every year a big conference. This year it was 18,500 people. Not everybody came to my presentation, unfortunately. So the fundamental role of every web application is to be up and running 24/7. But it's a huge challenge to do this at scale. Right? So it recently happened to BuzzFeed when they published an article that went viral and they had huge scalability issues to manage that traffic. It happened to New York Magazine, right? When a hacker brought down their website. It happened to Flipkart when they launched a product. It's a low-cost smartphone that a lot of customers wanted. It's kind of like an exclusive launch. I guess I don't know if anyone else had these kind of experiences where the application being brought down at scale. Anyone? Oh, let me see. So me personally, I also experienced something similar back in 2009 when Michael Jackson died, and the breaking news brought down our web application, or actually the entire platform, affecting 35 websites. So it was an unpleasant conversation with my manager. So it is a big concern for us that 87% of the applications are affected by this kind of attacks. Right? An average downtime costs us hundreds of thousands and millions of dollars, not to mention about damage in reputation and credit rating, right? As well as customer churn and insurance premium increases. So is there something really easy or manageable that we can do as developers that will help fundamentally solve these problems? We've been doing this for a while, helping customers, either it's business owners or decision makers, either it's developers or architects, either it's technical or non-technical people. We help everybody improve their web applications to be resilient. So that's how we ended up using the abstracted services from AWS and building a platform as a service that we call Digital Enterprise End-to-End Platform. So the short acronym is DEEP. My name is Eugene Estrade. I'm the partner at Mito Group. I've been in IT for over the 15 years, the last 7 years working on AWS. I'm a certified solution architect, and I work with companies like Hearst Corporation, Amazon, Grubhub, Tenaris. Mito Group is a web development studio that focuses on enterprise applications and platforms. We are official AWS technology partner, and most of our customers are from media and entertainment industry. So this presentation is structured in three major topics. So we'll be talking about services architecture, the serverless architecture. We'll be talking about microservices architecture, and we will do hands-on demos. Right? We'll do a couple of hands-on demos. Okay? So before jumping to my goal today is actually to show you from a practical standpoint of view, hands-on, how we did it. At the end of the talk, I will demo this application that is inspired from todomvc.com. It's a very simple to-do app that we built with the full stack. We published it on GitHub. It's a very simple application, and there is a README where we'll be describing step-by-step how to use it. Okay. So let me pause here and go to GitHub. actually, there you go. Interact. Is it Talon?
Talon, yeah. Either one. And then 11. Yes. 11 EAST 44 TH.
44 ST.
11 East 44th, so 11 EAST 44 TH.
Yeah, it can work. Okay, thank you. So, to do application, you go here and scroll down, you have this small paragraph that tells you how to get started. Right? I will skip the first step and the second step because I'll do that at the end. And I'll jump right away to, actually, the first three, I'll jump right away to the fourth step. Because it takes a little bit of time to provision the infrastructure on AWS, so I'll do this directly. So I already have it downloaded here. Let me see if okay, everything is fine. Deploy, source. 1 second. It takes a little bit of time because it creates a copy of your application. It pulls the dependencies and it prepares it to be deployed into on my AWS account. So I already compiled the libraries. We're using ES6 as a standard, so it's already transformed it into ES5 and loads it because the Node.js, Lambda supported right now Node.js 0.10. Okay. All right. So let's go back to the presentation, and we'll get back to this slide. Okay. So let's start with the reference architecture on AWS. By show of hands, let's see how many of you use this or similar reference architecture. Let me step back. Let's see how many of you used AWS before. Okay, that's good. How many of you used EC2? Right. Lambda? Good. All right. S3? Okay. It's a very good crowd. All right. So, in a nutshell, this architecture. By the way, guys, you can see it back. Okay. In a nutshell, this architecture, because it spans across multiple availability zones, which means in terms of AWS, it's actually different physical data centers. There are millisecond latency apart from each other. So that's why, in terms of scalability, it's very fast. It scales in minutes. But the problem is when you have to, if you experience breaking news or viral content or some various attacks on your platform, you know that scaling in minutes is just not enough. We, by ourselves, we had to build additional complexity into the application to be able to scale it faster. This architecture on AWS also helps us maintain and support the application easier. Less operations makes the application less complex. Right? But you still need experienced DevOps engineers who actually know what they're doing. As developers, we have the flexibility to choose what languages we can use. JavaScript or Java or C#, Python or Go, JavaScript or JavaScript. Supposed to love guys. But it requires developers to have a very rich experience or skill set to be able to manage the entire stack. Last but not the least, it is cost effective. Only if you do it properly. Right? You are paying for whatever you're using. Right? But whenever the infrastructure doesn't scale fast enough to meet the spiking demand, the engineering teams that's what we usually do, we're over-provisioning in order to solve a short-term problem and buy ourselves time until we figure out a long-term solution. Anyone here did it before? Obviously. So while we're trying to solve all these problems for our customers, two major things happen on AWS. First, last year, Amazon launched AWS Lambda, which is an event-driven computing service for dynamic applications. And this year, at the New York Summit, AWS launched Amazon API Gateway, fully managed service for scalable API endpoints. These two new services helped us to reinvent the reference architecture into a serverless approach. So let's dive into this serverless approach. What does it mean? So first, what does serverless mean? So intuitively, you think that it has nothing to do with servers, or it has to be something that with no servers. Right? And generally, it's true. The reality is that developers don't need to deal with servers. Right? The servers are there, but you as a developer get some abstracted services that you don't need to think about how to scale them, how to provision them, how to make them highly available, secure, and so on and so forth. The list is very, very long. So let me show you how did we get from a reference architecture to a serverless one. I'll try to describe it layer by layer. Okay. So the first question, how do we transform the web tier to a serverless one? Okay. So most of us think of S3 as a storage service, right? Available over the internet. We think of S3 as a collection, or as a cluster of web servers that are behind load balancers and have turned off server-side scripting modules. Right? So it means that you cannot run Python or PHP or Java, but you can run some client-side languages like JavaScript. Correct? It is secured through Identity and Access Management, IAM, and you don't need to worry about the underlying infrastructure. So as we do this transformation, the static component stays exactly the same. Right? So we load everything on S3. It's CSS, JavaScript, documents, images, videos, and even HTML, which usually it is served by EC2 or by the computing layer. Right? Because S3 doesn't allow server-side scripting, we are using client-side languages, right, like JavaScript, to add dynamic functionality. Modern JavaScript frameworks like AngularJS already provides, they caught up a lot lately to other modern web frameworks, right? Like Symfony, like Django, like Rails, and so on. They allow, and they are very friendly with search engines, right? Allowing indexing of the content for both new applications as well as legacy applications. But the most important, it is completely serverless. So what does it mean? Right? It actually comes pre-scaled at the AWS size, which virtually is infinite. I heard some customers saying, quoting, "You will reach your budget faster than AWS will reach its physical limits." So the bigger it gets, the better it is for everybody, and the lower it costs. I can tell you from my experience. So the next question is moving to the web app tier. How do we transform the app tier to a serverless one? So AWS Lambda, because AWS Lambda is designed, because the way AWS Lambda is designed, we get out of the box an accelerated backend. We write some small Node.js functions, or it can be some others. We'll write small functions, we'll load it into Lambda, and they get consumed through API gateway. So it also supports caching, throttling, metering, versioning, and so on and so forth. That's part of the API gateway as a service. So you don't need to worry about this. Right? And again, as in case of web tier, it is completely serverless. Right? So you don't need to worry about the infrastructure. Last but not the least, switching to database layer, how do we transform the database layer into a serverless one? So technically, or we recommend to use DynamoDB. That's the equivalent of MongoDB. It's a NoSQL database. Right? It's a key value pair database, schema-free. Right? And as a developer, you have to think only of two operations: reads per second and writes per second. Okay. All right, and another thing that I want to add here is that you see here SQS, which is a queuing service from AWS. So, did anyone hear of Shazam?
Yeah, Shazam's a comic book.
No. Shazam, no, Shazam is the mobile application that recognizes music and television, TV around you.
That's close.
Okay. They were the first one to blog about how to put or virtually expose SQS in front of DynamoDB, so you upload your writes to the database. And obviously on the read side, you can use a caching layer like Redis or Memcache. Okay. And again, it is completely serverless. But if you, for some reason, are tied to a relational database and the transformation to a NoSQL database like MongoDB or DynamoDB is hard, you can choose RDS Aurora, which comes close to serverless, right? You don't need to worry about the infrastructure, and it's a MySQL-like equivalent that is native in the cloud. I hope you guys are excited enough for me to show you a demo how to set up a serverless environment on AWS. Okay. So in this demo, I will go through this. What I'm trying to achieve is build a full stack application from the infrastructure and going up. Right? Infrastructure, platform, and the application. I'll go through these 5 steps. First with security. And I'll be mindful of our time, so I'll try to make it set up only the most important services and features. And obviously it depends on what kind of use cases that can evolve. And I'll try to make it short. There is a video on YouTube, which at the end I will post on the meetup that shows all this. It came already preloaded. Okay. So, for those of you who have never seen this UI, this is an AWS Management Console. Right? We will be using, as I said in the presentation, Identity and Access Management, IAM. We'll be using, so that's on the security side. Then we go to the front end, we'll be using S3, Simple Storage Service, and CloudFront. On the back end, we'll be using Lambda and API Gateway. And on the database side, we'll be using DynamoDB. I skipped SQS and Elasticache for this presentation. Okay? So as you can see, actually, they're over here, all the services, the shortcuts. So the first step is setting up and role in Identity and Access Management. So I'll create the role, say demo, to do app. In this case, I need to give access to Lambda to make calls to DynamoDB. So the first step is specify Lambda will be the one that will trigger the requests. And DynamoDB, there is already pre-built policy that gives you access to invoke executions on your DynamoDB table. All right, and that's enough for this presentation. One thing to mention here is that as I move along, you'll see, guys, that for example, on S3 or CloudFront, when I'm creating in the UI, these roles they're created on the backend. This UI already does that for you. So the next step, we're moving to front end, creating a bucket in S3, demo to do app, specifying the region it created. The second step is to enable the static website hosting to make it as a web server. And that's how you do it, specifying the index document and the error document. You're done. And the third step is to go here and upload the code. I will enable this enhanced uploader because I have a lot of files that I want to run. Let's start this again. All right. And there you go. And then download. Sorry, not here. There you go. All right. So while this is uploading, I will move on to the next layer. We'll go to CloudFront. So in terms of CloudFront, one important thing to, if you're working in the UI, is when you click there, it already shows you the list of your buckets. What's important for you to remember is that we want to specify the bucket, but the endpoint to the S3, right, to the static website, which already done. So you can go back here to the static website hosting, and it shows you the endpoint. Right? So this is the first trick that you have to remember when you're working with UI. Because once you switch, you see that now it appears as a custom integration to this. So it's a custom distribution. It's not a direct integration between CloudFront and S3. So technically, what you need to do here is just enable options, specify the default object, and be done. Right. So this step, CloudFront actually takes up to 15 minutes. That's why at the beginning when I launched my stack, because of this, right, it takes a lot of time. So moving on to the backend, next step is creating Lambda. And with Lambda, I kind of already preloaded over here. Let me delete one of this and recreate it again. So you click Create Lambda, you skip the blueprints, put the name of your Lambda, upload the code. So you can, so Lambda now supports Node.js, it supports Java, and it supports Python. Well, we're using Node.js. Let's go here. It was retrieved. And this is where we're specifying the security piece. Right? This is where we're going to that IAM role that we created and show it to you over here. Right? And the handler, it's specified here by default, but that's a thing that you can customize if you want. And the timeout of Lambda execution, right now it's up to 300 seconds, so it's 5 minutes. I'll just bound to the ISO. We're creating function. Once the function is created, right now it uploads the zip file and it loads into Lambda. So once the execution is triggered, they take your zip file and they load on the container. Okay, that's good. So we're done with Lambda. Moving on to API Gateway. Create a new API Gateway. We'll call it again demo to do app. The next step is to create a resource. So have anyone worked with Swagger before?
API documentation.
Yes, the API documentation. Sorry, getting old. So it's more or less the same approach. Actually, API Gateway supports Swagger, so you can import Swagger and export, and I think they also support RAML. So create a resource. In this case, we will say this is to-do app, right? And the way we're doing it is for any kind of interaction or any entity, abstracted entity that you think, we create 4 lambdas to have. I'm sorry, no, I think it's. Yeah.
It's not personal.
No. Nothing personal. Okay, so what happened?
Big wall screen or something.
Yeah, something. It's a no. Okay, there we go. So let me see. Let me do this. Okay. Let me do this.
So there.
What happened? Yeah, I think it's something related to the settings. Display.
Are you plugged into a power source? So that's sometimes matched to the kind of like.
No, I don't think that. Okay. What was the problem, I guess? Alright. So for every resource that we create, or every, sorry, not resource, but the entity, the abstracted entity that you think, we create kind of like a RESTful approach, where you have the CRUD for that particular resource. So you have create, update, retrieve, delete. So I'll just create only one, the retrieve piece, and it can be applied the same. So create resource, I will name it retrieve. Okay. It is part of the to-do app. And now when I have the resource, the next step is to create a method. And the method corresponds to the HTTP method. Right? In this case, we have post. And I want to point my API endpoint to the Lambda function. As you can see, it supports some HTTP proxies, so it can be anything else. It is RESTful compatible, right? And you can have some mock integrations. So in this case, I have demo retrieve, right? And this is the function. This is the endpoint that gets created. What's important to notice is one thing. So when you load application on S3 and you try to call it from a different domain, you need to enable CORS to allow JavaScript to make a call to a different endpoint. Right? So there is a button here that's called Enable CORS. Just click, done. And that's basically the steps that actually last month at the event I did these steps manually because they didn't have this feature. And it takes about 5 to 7 minutes. So right now we have we define one resource, we define one API endpoint, and we can deploy it. We have to specify what kind of stage or what kind of environment they have. Production, staging, testing, and so on and so forth. So we specify prod. And there you go. You have your API endpoint. And if you go to a particular resource, into a particular method, you have the full URL. Okay. Moving on, last but not the least is the database. So the database, it's very simple. Just point demo to do app. In DynamoDB, you have to specify one key. The key can be a primary key or it can be compound of a primary key and a range key. So again, good practice is just start with ID. It can be string or it can be number. Usually it's number, right? And that's pretty much it. So now the DynamoDB is created. They set up the, as you can see here, the provision reads per second and writes per second. Once I'm done, it should be done in a couple of seconds. Let's see if CloudFront is enabled. It still says it's work in progress, so I'll just show you the application over the S3. Right? Just clicking this button, and it says permission denied. Because I forgot another step. Make it public. So you can do the way I'm doing it right now. Every object will be made public, or you can go on. That's part of the security setting. You can go to on the bucket level. You can go to permissions, and here it says the bucket policy. It's the IAM policy, only you set up directly on the service side. Right? It doesn't go through IAM. So you can go here, and there is sample bucket policies that you can choose from. And I usually go to the second one that says granting read-only permission to anonymous users. Copy this one, go back, put it here, change the bucket name, demo to the app, and there you go. It should work now. Again. Ta-da! So that's, if you go to todomvc.com, I can actually show you. That's how it looks, right? And we've done exactly the same for our application. Okay? Any questions, guys, so far? All right.
So you have a duplicate. What's going to do is the demo you created with this, or a duplicate of.
We took the just the AngularJS app from the To-Do MVC, and we put it on top of this stack that we've created.
Okay.
And it's the whole process of deploying, putting on AWS, and running. The front end runs the AngularJS app. The back end is powered by AWS Cloud. So get into there, and at the end, I'll post also. You'll see the link to GitHub project where it's publicly available. You can take a look at the code. And it also describes the structure of the entire microservice. Okay. So what we've learned, first of all, it's the serverless approach is cool and it's challenging. Right? Some developers they don't appreciate this challenge. Mainly because, well, it's outside of the comfort zone. We actually like it a lot because it forced our entire engineering team to focus only on JavaScript. Right? The entire full stack is JavaScript, and avoid those endless language flame wars. That was one of the biggest benefits out of the box. The second one, which I personally like, is not having alternatives to services-oriented architecture and application programming interfaces. It should make everybody to commit and build SOA and APIs. That was the best way to get the engineering team to commit to that. SOA also means that we build services. Right? But Lambda, AWS Lambda is constrained by design to 300 seconds execution time and 1.5 gig of memory. Not to mention the browser limitations, on the responsive design, especially on mobile devices. And that's how we ended up adopting microservices, which I'll be talking about next. Okay. So, microservices architecture. So what does microservices mean? Well, in a nutshell, it's an architectural pattern that can be applied actually anywhere. Either we're thinking of on the infrastructure level, or we're thinking on the operating system or platform level, or we're thinking on an application level. So, to quote a friend of mine, it's a threat of the monoliths, right? Where you take a monolith, you go through this shredder, you get very small pieces, then you put them all together. It sounds complicated, but once you get used to this process, development process, which I will be talking about in a couple of slides, it becomes so simple that you never want to go back to monoliths. So microservices architecture is the new trend. It gets a lot of developers very excited. The speakers that I like that talk about microservices is Adrian Cockcroft, Martin Fowler, and Sam Newman. I mentioned Adrian Cockcroft for two reasons. He's actually the former chief architect at Netflix, the one that pioneered and evangelized microservices at Netflix and to the entire world. And the second reason is that in his presentation, State of the Art in Microservices, Adrian is talking about how to speed up digital platforms. Right? The milliseconds in deployment time and the seconds in execution time really turned us into early adopters of AWS Lambda. So let me show you a use case powered by AWS Lambda. This is a third version of publishing workflow, which, by the way, the first two we completely messed up. If you guys want some details, we'll stop at the end. This is a little bit embarrassing. Back to this one. So we've built our customers. This is a use case for digital asset management, where our customers they have assets, images, videos, digital documents. Think of anything that is digital, right? Even microsites or some static websites, marketing websites. So we help them by building a collection of Lambda functions to migrate on AWS with just one click or one command line. So what happened is all these Lambda connecting to each other, what they do is first take the asset and load it into an inbound S3 bucket. Then it triggers some other Lambdas that does the processing, extract, transform, load some metadata, loads into DynamoDB, or get some metadata, update some metadata well S3. Right? And at the end, it takes and it puts into outbound S3 bucket after it's get processed. Right? So because of that, well, Lambda scaled for us with literally no effort. Right? So we had at peak, we had 10,000 requests per second, and it was able to handle it out of the box. Right? And remember these challenges that I talked at the beginning of the presentation? So Lambda really helped us out of the box. Right? We love its pre-scaled nature, right? Where you don't have to think about the infrastructure. Developers they particularly grew attraction for Lambda because it's designed for simplicity. Actually make it easier and simpler. And the DevOps people, they are still in a experimenting mode, trying to write ops code because it's a completely different approach. So let me share some tips and tricks while we were using AWS Lambda in production. So AWS Lambda is about 1 year old. So the first thing that I personally recommend is be open-minded and expect the unexpected. Set up alarms on the AWS, on all of the AWS Lambda metrics. You'll thank me later for that. For example, there is a use case which I never thought we will get there to hit the threshold of S3. And if you put SNS between S3 and Lambda direct integration, we were able to handle that threshold by delaying some of the executions. And last but not the least, be aware of potential infinite loops. It is actually in the official documentation, which we read, we were aware, but when you think of that applying it to one Lambda, it actually can be applied to, we had 2 developers working on different Lambdas, and they ended up in a loop. Some of them were calling others, and it was like an infinite loop, which after a couple of hours got really spiked on our build. So it wasn't pleasant at all. Microservices are game changers because they're designed for, they enable speed and security. Because it is really hard to figure out how to attack something that disappears really quickly. Right? But if you're coming from monoliths, the practical approach is take and build a service or a feature first, and then shred it, break it down into microservices. Right? So most of us, or traditional development process or monolithic development process, looks something like this, right? Where a lot of developers are expected to follow the same process. Right? I don't know about you guys, but in my experience, it was very, very tough. While microservices enables and empowers developers, to bring some color into the monoliths. Right? So every developer can be completely independent. Right? They self-sufficient, highly decoupled from each other. Right? They don't need to step each other's on toes. Right? It is focused on simplicity and on small tasks. Right? But the one thing that I personally really like is developers can define their own process. So everybody has their own speed, they have their own schedule, how to do it. Because at the end of the day, what we care about is to get the work done. So honestly, I personally love this approach, and I hope I never go back to monoliths, ever. So finally, to the demo, back to the same slide. We'll try to show you guys. So I'll go back to the documentation, right, to the README file, and I'll take step by step. I'll try to explain what we did to help to make our job easier. And last month at the reInvent at the conference, we open sourced it so anyone can use it. Okay. Any questions before we go to the demo? All right. Okay. So I will leave this here, open a new terminal. Oh. Can you guys hear?
It's good.
You guys see it at the back? All right.
One more command plus.
What?
One more command plus.
One more command plus.
Command plus.
I'm a programmer. I'm blind.
I was doing like this.
Thank you.
I'm in the front row. I got my glasses.
So if I go back, let me just kill this, make it simpler. All right. If I go back to this repository in GitHub and go to the documentation. So the first step, it says install the deep CLI. We call it TP5, just to be a little bit cool. And it's just a Node.js library. And honestly, all the functionality that we've built and we labeled it as a framework, technically it's just another Node.js library. It decouples the service, the web application from a particular cloud service. Okay. So the first step is you go there, you go to the command line and install TP5 globally. And because I enabled it, it shows a lot of information, what happens. Technically, it's already installed on my machine. For the sake of the demo, I want to be credible. And yeah. Okay, so if you run DP5, it should tell you that you are running the version 1.2.17. This is probably the latest version. And it also tells you what are the available commands. Right? So going back to the documentation, we've installed the CLI. The next step is to get the application. Right? Getting the application is just cloning the GitHub repository. Okay. So I cloned it. The next step is to run the application locally. So what we've done, a lot of work, is to take this approach of a developer should be able to work even if they don't have access to internet. Everything runs locally on their machine, so we simulate everything. Lambda, API gateway, DynamoDB, and Elastic Cache. Obviously, it's just Redis or Memcache. A queue, right? SQS. Right now, it's not implemented, but we want to do that. And as well as a file system. So if you run the server, it literally doesn't make any connections to outside, right, to AWS. It just runs locally on your machine. So you can develop locally. Once you're comfortable, you can push into on remotely in the cloud. Okay. So if I do something like this, in theory, what happens is it asks me a couple of parameters. So we set it up as any application. You should be able to set it up, and you either can put it in the package.json, which technically it's not package.json. I think it's parameters.json, something like that. So I'll just use the default ones. And as you guys can see, right now it takes, in our application, in the Studio app, we have actually 6 lambdas that gets executed. So every lambda here goes and it installs all the dependencies for the lambda. So right now it did and it tries to do 2 at a time. So right now it runs the compile step. It pulls all the dependencies, transforms because it also runs Babel because we're using the S6, and so it should be back compatible to ES5. All right, it's getting closer. While it executes here, let me scroll down a little bit further and see. As I said, here's a layout, an example of what files you can find in this microservice. So the microservice, the way we define it, okay, perfect. So it runs. You can see it's running on a local storage, local host at port 8000 by default. That's what we set it up. And you can start and poke around here. Say I want to disable this one. And if you go back to the terminal, it actually shows you everything that happens, how much time it takes to execute, what was the response, and so on and so forth. Okay? So the same benefit as you would run a local server on other framework like Symfony, Django, or anything else. Okay, so let me switch back, and as I was talking about the directory layout, so we the structure of every microservice, if you use the stack that we're trying to put together, is the front end, and it starts with Bootstrap.js, where it defines what is the front end framework is used. We're using AngularJS, but we thought that we can support, or we can give the developers the power to choose what kind of front end framework they would like to use. It can be React.js, it can be Ember, it can be Backbone, or you guys name it. The backend, again, the main file there, it's resources.js. It's the mapping between what kind of resources do you have here in your folder. In our case, it's 6 lambdas that executes 4 lambdas for the CRUD, create, retrieve, update, delete. And there are 2 additional operations in that to-do app that you can mark all, and then you can delete the one that are completed. And if I scroll down a little bit, you see the models. We define the models, which maps to the database layer, as well as what we're trying to do is to help developers to build applications that are fully compatible with the entire continuous integration and continuous deployment processes. So we encourage, and we have some of the documentations that are already pre-published for a particular microservice, as well as the unit testing for the front end, for the back end, database, mocks, and so on. Okay? So, you guys curious? Yes.
You may have mentioned it, or maybe I can't see it on the board, but what's your opinion on CI servers?
On CI servers?
Yeah, is there CI anywhere?
Yes. So we're using Travis.
Travis?
Yeah. So we enable Travis because it's free if it's an open source project, and we are actually using the paid version for our private projects as well. Because Travis is one of the most easiest one to set up. It's just .travis.yaml, and you take it from there.
You have Travis set up that on a successful test week run, and it deploys directly to production?
It's only continuous integration. It doesn't go into continuous deployment. Yeah. Continuous deployment, it's there is some value there, but it literally, because of the command line, the CLI that we wrote, we can just have dpify deploy at the end, and yes, we can do that.
I see. So in your integration process, it's that Travis will serve whether or not the test suite is saying it or not. So who needs the word redundancy cap? Right? And then if the test suite is ready, then someone manually will deploy the application?
I missed the last part.
Someone will manually deploy the application on a successful CI run?
So that's how our team works. We have a full process of the developer who builds the application who builds the microservice is in charge of running and deploying it. So, and everyone chooses their way how they want it. If somebody wants to sleep at night, they usually don't set up on auto deploy in production because sometimes stuff happens and not all the unit test catches all the issues. But others, yeah, they prefer to set up this like blue-green deployment where you can set up a fully new infrastructure and take some of the stuff, migrate from production to like, especially on the database layer. Right? You get all the data, you get all the lambdas, they're stateless, so we don't store anything on lambda because it just executes and it disappears. Right? So we store everything on the database layer, either it's DynamoDB or it's in Redis. We're using Redis for the caching layers, as well as SQS to offload those eventual consistency use cases, so you don't get charges. Because DynamoDB at scale, it's very expensive.
I see. So this is good for batch processing. I think you have to. So I worked with an app with in fintech. And basically, every once a day, there has to be a batch process of updates from the stock market.
Yep.
Essentially, all that is just a whole big folder or zip file of like SQL diffs.
Yep.
And so this is a setup that you run, and you have to like go through that entire batch at midnight every single night.
Yep.
And it's, I guess, then it becomes a game of which Lambda finishes first.
And you don't, yes. And you just need to keep in mind that Lambda Lambda, the execution has to be within 30 seconds. If it's more than 30 seconds, there is a blog post on AWS blog which talks how to use Lambda for orchestration. Then if you have long polling executions or compute jobs, then you use ECS, right? EC2 compute container service that basically runs Docker on top of EC2. Okay, so let's go back. Did I answer your question?
Absolutely.
Okay. Let's go back, and the last step that I wanted to show here. So the server is running locally. Doesn't interact anything with AWS. You haven't seen me inputting any credentials for my AWS account or specifying any particular role to run on AWS account. Right. So the last step is what I did at the beginning. Is as you can see, let me increase so you guys can see at the back as well. I run dpfi deploy. So it was the last step here. Right? So I ran dpfi deploy. It asked me if I want to run it in production. The reason why this step is here is that, as I said, we simulate everything locally, and the local DynamoDB, local Lambda, and all those libraries, there are Node.js libraries, which we put in developer dependencies. And by default, it gets packaged into Lambda. It makes Lambda really, really huge. And that's why we put this step to install with a production flag, so it skips the developer dependencies. Okay. So it compiled this one, right? Took the node dependencies, then it went to package Lambda, and here it packages the code. It makes one zip file, and then uploads that zip file on AWS. Okay. Once it's done, you can see that it says it's installing a web application. It puts a hash, and based on this hash, it identifies all the services that are provisioned: S3, CloudFront, Lambda, DynamoDB, and so on and so forth. Right. So I encourage you guys to try it by yourself. I will scroll at the end, and I'll show you that it says CloudFront CDN. Loading CloudFront, and there it is, the application. Questions?
Makes a new architecture. So.
Are you guys speechless? Should I start from the beginning?
Yeah. How do you like working with DynamoDB? Like how, I guess it's pretty reliable, but I guess what are some of the issues you come across and how easily can you troubleshoot positions in the pods?
The only issues that I can complain with DynamoDB is when it gets very expensive. But that's the reason why we've built this collection of Node.js libraries, and we're trying to, so that when a developer makes a call to the database library, so deep-db, the default use case is the eventual consistency. So it puts on SQS if it's a write first, and then once every, I think right now it's every minute, takes from SQS and tries to save it into DynamoDB. If it fails, okay, it's fine. It will retry the next time when the cycle comes. Obviously, it's not fast, but it's cheap. Right? That's the goal. It's, well, not cheap, but low cost. And that's the goal of our framework, to be low cost by default. And the developers are the one that decides, well, my use case is not the eventual consistency. Like, for example, can I wait for a file to be processed a minute later or 2 minutes later? Yes. Can I wait a transaction, a credit card, to be processed a minute or 2 minutes later? Probably not. Right? When I run the transaction, when somebody buys from me, I want to tell them, yes, everything is fine. And then in that case, what we do is we increase the writes per second if the write fails, and we increase it 3 times by doubling the limit. If it's over 3 times, it doesn't write, then it might mean something is wrong. Right?
From an architectural perspective, aside from being NoSQL, DynamoDB, it can be used similar to MongoDB, but it's more akin to a key value store, like say HouseDB or something like that.
Gotcha.
So we have like skinny tables, because you only get a primary, if I'm not mistaken, a primary index and a range index, a secondary index. And so